Hello out there to you. In this video, we're going to think about perfect competition. We've got this firm graph. Sometimes the graphs can be a little bit, there's a lot of lines here. So my suggestion would be to color them. We're going to go marginal costs, color that light blue, then average total cost. You can color that pink. You can color whatever color you want. But just something to differentiate. It'll help your brain to see the different curves. We'll color this one yellow. Okay, and let's say that these are in Bangladeshi takas is the currency here. And cover that up, and here we go. So you want to find, well, first let's just do the quickest one. When will the firm shut down production? So this is at the minimum of average variable cost. Okay, so any price that is less than the minimum. So just find average variable cost. You're going to go to where its minimum is, and that is 220 takas. So any price that's lower than 220, we are going to shut down. Okay, so that's the answer to C. Optimal production level in the short run. Well, that really depends on what the price is, right? So what price we would like the best for this firm would be the highest. So if I had a price of 500 takas, then we would just follow this over here. This is our MR, and that would also equal price because this is perfect competition. We follow that down to 10. So we would make a difference. So we're going to compare that to average total cost. So our price would be 500. Our average total cost would be 310. So we would make 500 minus 310, 190, and we would make that on 10 units. So the optimal production level would be 10, but in order to get there, we would need the price to be 500. Okay, so that's probably the answer to that one, and that's part of this answer here. Now, I guess I'm not doing this in order, so let's go ahead and show the supply curve before we do the rest. So supply curve is going to use this idea here, so we're never going to produce any less than this number of units. So the supply curve would actually be the marginal cost curve, but up the, so I guess let's go ahead and color this green. It would be beyond the shutdown rule, and it just follows that marginal cost. Okay, so it starts off here, and if you were writing this, it would be like price of 220, and then what would be the quantity? It'd be around 7. And then when the price went up to 260, all that over there, how many units are they going to produce? They're going to produce 8. This is just this particular firm. If you wanted more firms, you'd multiply that by the number of firms in the market. 500, follow that over to 10. And this is actually your supply function if this is the only firm. And if this is exactly like other firms, you just multiply those quantities by the number of firms in the market. Okay, let's do all of these. So total cost when the quantity is Q1, which is 6. So we're going to follow that up here. The formula that we're going to use, average total cost is equal to total cost over quantity. We can also use average variable cost equals variable cost over quantity. So for this one, quantity is 6. Average total cost is 330. And then we don't know the total cost. So we would know, it would look like this, 6 equals 330, and then that would be total cost. Rearrange everything so that total cost, I guess we can make a little table here. So what we're doing is 6, 8, and 10, total cost, and it would be 330 times 6, 1980. Okay, then we want to find the variable cost. We want to find the fixed cost. Oh, we want to find the profit. Okay, it's a little bit longer. Profit going to be total revenue minus total cost. Okay, so then when the quantity is 8, let's do total cost. So it'd be 295 times 8. It's the same concept here. 295 times 8, and that would be 2360. 60. And then for 10, we would do 310 times 10. So that would be 3100. All right, now we're going to do the same thing with variable cost. And if you look at what I'm doing, right, if you rearrange this, average variable cost times quantity equals our variable cost. So it's like just rearrange that formula there. Okay, so quantity 6, it would be 230 times 6. 6 is 1380. And then times 8, so 230. And I guess that's 220. 220 times 8. And that means that my answer down here is a little bit lower. That'd probably be more like 210, any lower than 210. But 220 times 8, that would be 1760. And then 10, we do that one in our head, that's 2300. Okay, now our fixed cost is the since total cost is variable cost plus fixed cost, is the difference between these two. And it's always going to be the same, just to make sure I get it right. 1980 minus 1380 is 600. The difference there is 600. The difference there is not 600. Uh-oh. That can't be right. Oh, because down here, that's because that's a mistake. It's not 2300, it's 2500. Maybe you caught my mistake. 2500. And that's 600. So it's 600 all the way down. And see, by doing the math, you can catch any mistakes that you make. Okay, total revenue minus total cost. Okay, so we've got our total cost. We just need total revenue. So in order to produce 6 units, we would need a price of, well, this is going to be a big loss, 140. Okay, so the big loss is going to be more than 600. So down here, the profit is the difference between these two. So I could also do total revenue, and then total revenue is equal to price times quantity. I'm going to do it that way because I already calculated total cost. So price is 140 takas times 6, 840. So 840 minus 1980, because that's our total cost, would be negative 1140. Negative 1140, and that's why we would shut down at that number of units, because I'd rather shut down and pay the 600 than produce and pay and lose 1140. Okay, on this one, I'm going to find 8. Okay, so in order to produce 8, it would be 260. So 260 times 8, that total revenue, 2080. 2080, I don't need to write that. Just put 2080 minus the total cost of producing that many. That would be negative 280. And then, so we're still losing money. We're losing money everywhere. It's below 295. And then in order to produce 10, I actually already did this one, but we'll do it one more time. So it would be 500 times 10, which we can do in our head. 5,000 minus 3,100, and that would be 1,900. Is likely where it got the optimal level of production. Okay, and that's how to take apart that kind of graph and think about it when it's perfectly competitive.